This video was funded by the Great Plains Biochar Initiative as part of a larger grant to evaluate eastern red cedar as a biochar soil amendment in eastern Kansas. Throughout this video, we will demonstrate the use of a Kon Tiki Biochar Kiln to evaluate the process, or basically document the process of creating biochar using the kiln. And as part of the greater project, we also evaluate the quality and the quantity produced from each batch from this prototype kiln. Before we get into the video of what we did as part of our experiment, I just want to give you some quick background about eastern red cedar. Eastern red cedar is a conifer. It is not a true cedar. Its scientific name is Juniperus virginianus, so it's a juniper species. Eastern red cedar is a native species in all the eastern U.S., ranging throughout the states east of the Rockies to the east coast. In fact, it's the most widely distributed conifer that we have in the U.S. And prior to European settlement, woody tree species were mostly confined to riparian areas throughout Kansas and the Flint Hills region of the state, as well as some rocky outcrops that were protected from fire, partly due to shallow soils and just less fuel load from the grasses and forb species to spread the fire up into those protected bluff areas. ERC mostly occurred on the periphery of riparian woodlands as well, probably where they could compete on the edges, and further upstream and more upland areas along the riparian areas where they kind of interacted with the fire and the water table, and if it was moist enough they could survive and the fire couldn't penetrate too far. However, if it was dry or there wasn't too many trees there, the fire kind of pushed them back, and so it was that interaction that kept eastern red cedar at bay. Also, working with that fire, which was both caused by natural causes and it was managed by Native Americans, and then also grazing kept eastern red cedar in check too, seedlings from spreading, and especially in interaction with the fire. But since settling of the area, we have fragmented the landscape over time by constructing artificial barriers to fire, which would have been set periodically prior, maybe approximately every 4 years. And now we have these artificial barriers like roads that halt natural progression of the fire, allowing cedars to expand their presence over time. So sometimes poor land management of the grasslands or just altered land management, such as fire suppression in areas that we have developed housing communities or small towns, and some of these things have allowed cedar to expand. And we used eastern red cedar as a quality windbreak throughout much of Kansas. Birds often will spread eastern red cedar, and other wildlife will spread it by eating the berries and then defecating it in different areas, and that creates an explosion of eastern red cedar over time. And these processes have accelerated the spread of eastern red cedar. And according to a study by the Kansas Forest Service, they estimated that there was a 23,000% increase in eastern red cedar volume in Kansas that occurred between 1965 and 2005. And in the last 2 decades in Riley County alone, the expansion of eastern red cedar has increased by 382%, mostly moving into our grassland and upland areas. I live in a community called University Park. It's about 20 miles north of Manhattan, and it's developed into a little hamlet of 200 people. And in this hamlet, we have seen a lot of cedar expansion. This was all upland tallgrass prairie at one point, and you can see the eastern red cedar encroaching on the riparian forest. You also see it going into the grasslands quite a lot. And there has been some management out here. It is part of a fire-wise community where there was some funding to remove some of the cedars, but we still have a pretty expansive problem. And so I'm going to highlight on my land an example of where I need to manage eastern red cedar, and I would like to turn it into beneficial uses. I have a range of beneficial uses, but one of those will be biochar. That's the topic of this video is today.
Okay, today we're doing a biochar trial 1. It's the 5th of July, 2019. Before us is the, on this trial, we're going to look at taking logs, branches, stems, and leaves from eastern red cedar. These were cut down about 3 to 4 weeks ago. They were part of some prairie clearing. You can see in the background, tall grass prairie with cedar encroachment. This is my land. I have approximately 10 acres. 6 acres are approximately grassland, but a lot of it has a cedar encroachment. And I also have some windbreaks along the ditches that I'm kind of thinning out as well. You can see some of that going on here. I'm utilizing the materials. They've been cut approximately 3 to 4 weeks ago. There you can see they're kind of drying out a little bit. I've tried to pick a mix of materials. In this pile I have four trees at their base. I'm not looking at diameter or breast height, but at their base, all of them are, well, 3 of them are less than 2 inches, and one of them is just a touch over 2 inches in diameter. Majority of the whole trunk is less than 2 inches. I'll separate this into parts. The leaf parts, leaf and branches, less than 2 inches, and all the little pieces that are 1 to 2 inches from the stems. This pile here, I have 2 trees. They are approximately a little less than 4 inches at their base. And again, we'll take the branches off this and we'll measure the weights from the branches and leaves, and then the trunk inputs into the biochar reactor. Trying to get kind of a range of materials here for this trial. The main thing is just to see if eastern red cedar biochar has any contaminants once it's turned into biochar. There's a range of tests that
the International Biochar Initiative and the European Biochar Certificate specify for testing the quality of biochar. These tests basically analyze basic physical properties of the biochar, like its carbon content, surface area, its total ash content, its pH, bulk densities, and some of these factors. It's a whole suite of these factors that I'll show us a slide of as part of this presentation. And they also analyzed its chemical contents, and that would be things like heavy metals, mercury, arsenic, lead, these ones that are contaminants and that can harm us, and then things like zinc, magnesium, and boron that in high concentrations would be a contaminant, but low concentrations are a micronutrient. We also looked at nutrients such as nitrogen, phosphorus, potassium, those nutrients that would help supply needed micronutrients and nutrients to food or plant growth, whatever you'd be growing with the biochar, as well as volatile organic compounds. And cedar has a lot of volatile compounds and aromatic as part of its aromatic oils. And these are also part of polycyclic aromatic hydrocarbons, which are often the constituents of oil products, especially when they've been burned. So we're going to test for these volatile organics, these polycyclic aromatic hydrocarbons, PAHs, and things like dioxins, furans, biphenyls, which are sometimes created, especially with oil as part of a burn process.
So we'll just test all of that just to make sure what this quality of this biochar is. The ultimate goal here, though, is that we would be utilizing the oil from this. Would be extracting it first, and then using the actual cedar as the cedar chips that have the oil extracted as a biochar. But in this experiment, we're just really seeing what is the basic components of eastern red cedar, ranging from these smaller inputs to these larger inputs. This last tree here is over 12 inches DBH. We're not going to utilize the 12-inch portion of this main stem or trunk here. We're going to take probably a good 8 feet of that and chop that out and utilize that in our Timber King 1220 sawmill once we get it all set up. To me, this material is more valuable turned into furniture than it is turned into biochar and cedar oil. However, it does have a large amount of cedar oil in it. But we'll just take the more of the larger branches and stems, and we'll again classify all this material into various its components. You know, how much of it's branches and leaves, how much of it is this larger branch material, and when then the portion of the stem that or trunk we actually keep for the biochar. And we'll be weighing this, and then also get eventually convert it to a dry weight, and we'll take all this material before it goes into the kiln, take all these components down and place them here beforehand, so you can see what the inputs are, and then we'll see what the outputs are from the actual biochar. Okay, here's a picture of the small, less than 2-inch trees, and approximately what they produced overall. This is the 4-inch base diameter trees, and approximately how much they produced. Here's the processed, just right around 12 inches or so basal diameter. That's at its base, not at breast height. And this is all of the branches they produced. Some of those are as large as nearly 4-inch branches, kind of like our trees. And this is the top portion of that still needs to be processed. Okay, this is the biomass and once it's processed from the trees that at their very base were approximately 2 inches or less. One was closer to 2.5 inches. So you see, this is the branch and stem material from 1 to 2.5, and a few pieces that are that big. Most of it's in the 1 to 2 inch range. These are stems or branches, I'm sorry, from about a 1/2 inch to 1 inch. And this is the leaves plus branches that are less than a 1/2 inch. So it gives you about, this was 4 trees. They were pretty sparse with their leaves because they were growing in a stand. Okay, this is the 4-inch basal diameter trees. I had 2 of them. You can see this is mostly stem material, trunk material, a little bit of branch material, where it's approximately 1 inch to 4 inches. And then the branch material that was 1/2 inch to 1 inch approximately, and then all of the leaf and branch material that was less than a 1/2 inch. And if you look at this and contrast it, this was 2 trees that were 4 inches, and then this was the 4 trees that were around 2 inches. So I mean, looks like approximately double the volume, and I have the weights, and I'll have a dry weight conversion. And finally, here's the 12-inch, approximately 12-inch diameter tree. I kept the portion that was 12 plus inches at its base and cut it off at around 8 inches. I think this will make a decent saw log for my Timber King over here. 12 to 20. I'll get some decent siding and planks out of that. I cut off, here's some of the 8-inch stump pieces and all of the material that was approximately 1 inch. These are branches and parts of trunks, mostly branches, 1 inch to as big as these 8-inch pieces. Here is the branch, the leaf and branch material that is ½ inch or less. And this was simply additional material. It ranges from about an inch branch or a little larger with all the leaves on it. I just simply don't have enough kiln space to process it all. So we'll get weights on this, but a much larger volume of material than the 2 4-inch trees and the 4 2-inch trees, but as you'd expect. But so we'll process all of this in one batch and see what the final quality of this char is. Okay, this is the entirety of the process, and there's my dog Clappy Jane. But here's the all of the processed inputs. This is roughly 600 pounds. Like I said, I'll get an exact number on the dry mass conversion. This is the beginning of the pyramid, and then I'll put a little bit of the cedar leaves on top to get the top lit fire started, and then I'll redistribute once it gets going, and I will be back in a bit with the fire. And you can see the kiln fire underway. I just did the top lit fire with some of the leaves and some of the small ½ inch to 1 inch branches, and underneath a lot of the 6, 8, 4 inch stuff. It'll take a little longer in the burn process. I'll add that early on, make sure it gets charred all the way through. Already I'm not seeing a lot of smoke other than from the leaves. What you should see once the flames get going, when they're lapping at the sides, they should arc back into the center of the cone and burn up the gases. I just wanted to give you a quick shot of the fire underway. Here comes char coming in the backstretch. Initial top start. Fingers going good. Step back. Not really producing much smoke. Flames are kind of lapping into the center a little bit. And that's what she looked like. In the old Kon Tiki Kiln. Sure if I got that last shot. So essentially I just redistributed the fire, got the Kon Tiki going, added some big wood on top. Producing just a little smoke. I think there's still just a few of the leaves in there. The leaves do produce some smoke when they first go in. There's also, but for the most part, got a pretty good fire going. Once I get a little bit more ash on top, I'll add another layer. So here's the fire after adding the second layer of big wood. Not producing much smoke. You can see the heat current coming off the top. It's about half full. Flames aren't leaping too high. But by the time we add all this material, I think it'll be pretty full. Okay, I just added a batch of small wood and some leaves on top of the big wood. Producing a little smoke from the leaves, but most of it's getting burned up in the fire. I find that the cedar leaves tend to smoke a little bit when they first get introduced, and then they char out pretty fast. But I think it's the aromatic, some of the aromatic oils that we'll be extracting at some point prior to this, but I'm curious just how well this works with the oils in it and what its quality will be in the end. Whether it'll have any high levels of polyaromatic hydrocarbons or furans or dioxins. We'll test for all that. The next set of inputs is some 1 to 2 inch branches and more leaves. We'll wait till we get a good ashy surface, although we're already getting there. That small stuff goes pretty fast. Here's what it looks like right after you add the leaves. Well, this is actually 30 seconds to a minute. You see a lot of smoke at first and a lot of black smoke. Thinking that is definitely the cedar oils. But already it's getting charred down. I'll smash that down and throw some smaller, 1/2 to 1 inch, or in this case 1 to 2 inch pieces on top, and spread it out over the top of that. So this is within about 1.5 minutes, 2 minutes of when I added all those leaves, and then had that big puff of black smoke. They burn up really fast, release that oil, I believe is what it was. And then I just put some 1 to 2 inch pieces all over the top, just letting them go. I'll let it quiet down and get back to its no smoke temperature. And when I get an ashy quality on top, I will add another set of leaves and some small stuff again. Just within a few minutes of adding that wood over the top of the leaves, you can already see getting the classic biochar pattern. Flames are kind of arcing into the center, no smoke really. So we'll let this get down to ash and do it, repeat. Second verse or third verse or fifth verse, same as the first. Here I've put a large load of leaf inputs into it. They just burn up so fast, and essentially then I just establish another layer on top of the small stuff to char on top. You can see most of the smoke and the flames are going toward the center like you expect, and most of the gases are being combusted right there in the very center. But if you look up top, you do see some black smoke coming out. I think, again, that's that oil. We'll let that calm down and we'll add some more small stuff on top. Okay, this is after a big roaring leaf fire, and then I put the stuff on top, and we got some smoke. I think I must have dampened the fire a little bit, because I think there's all that fuel load in the leaves. That's what I'm thinking. And it all got burned up and kind of left a little ashy deposit on top. And then I threw this wood on, and it's going to take a few minutes, I think, for it to get heated back up on top and settle down the smoke. Still trying to figure out the best order for adding leaves and when to add them, how much, because they kind of mess up the natural char process because they are so airy and have so much oil in them, or energy anyway. Okay, I stirred the leaves in a little bit, and the fire's getting hot on top again, and you can see that the smoke is dissipating, and you're starting to get dominated by fire burning up the gases. It's not there yet, but it's getting there. I'll give this a little bit of time. I put 4 big loads of leaves on there because I have so many to process, and I wanted to get some of those used up before the end. I also had some big wood that I wanted to make sure got in there and got charred, because doing some practice runs, I found that if you put big wood on at the end, it takes a while. It'll get some ash on the surface, but it won't be carbonized all the way. I mean, it won't be pyrolyzed all the way through. So I'm trying to add the big wood early, and then keep stacking on top of that. But okay, this is a couple minutes later. I just stirred it pretty good, and you can see that getting back to the pretty good Kon Tiki fire. I think I will suggest putting just a layer over the top with the leaves, and then maybe some small branches, and I'll try that next. The other thing to do is, I guess, stir it if the leaves, because they kind of create like a little bit of insulated barrier with all of the biomass they produce really quickly. So the fire isn't quite as hot on top, I think, until you give it a little stir and get some of that mixed around. Just a couple minutes later. Starting to get an ash layer on top. Fire got back up the temperature. I'll give it a few minutes, and then I'll add a small layer of leaves and some small branches on top. That worked a lot better. I just spread a thinner layer, put small stuff on right on top. Just had a small little gust of black smoke, and then pretty much looking pretty good. Pretty much a smokeless fire. A real nice fire. A couple minutes later, everything's looking pretty good. Starting to get a little ash. Here's my next input. So I'll spread a layer of leaves, and then some 2 to 4 inch branches. We've exhausted a great deal of that wood supply. If you remember how big it was, we're down to those inputs and these inputs, and we're in it less than an hour at this point. I added almost a trash can full of the cedar leaves, and immediately threw the 1 inch to 2 inch to 4 inch pieces on top. Almost immediately calmed down. A real nice biochar fire. making me kind of sleepy. Mesmerizing. Okay, you can see used all the fuel pile up except for this last little bit here. We got 1/2 inch to 1 inch stems and branches. Oh, branches and leaves. They're less than 1/2 inch. And then here's the fire. So we'll put those on there pretty quick, and then we'll be, once they're turn ashy, we'll be ready to quench it. Okay, last of the fuel. Leaves are on. Just a few more 1/2 inch to 1 inch material. Nice leaping fire, no smoke. Looking good. Okay, last of the materials in. Let it get to a nice ash on top, and then really, around the outer edge of the wood, and then we'll quench it. The beginning of the quench. Hard to see. All the smoke or steam. I'll just keep quenching it till it's pretty much filled up. Not a real exciting process, just gonna be a lot of steam. So. Okay, here's the quenched char. See. Just crumbles. Big piece. Lots of different textures in there. And that's it. So I will let this cool, and then I will probably put it on a tarp and drive a truck over it quite a few times, crunch it up, take a subsample, and then send it off to Germany for analysis. So I'll be back with you soon. Thank you.